Welcome back, everybody. We're doing math today, and we're looking at accelerated motion. I've given you a few distance formulas. The main distance formula that you learned was that the distance equals the initial velocity times the time of the entire distance plus 1/2 of gravity times the square of the time. So that's VOT plus 1/2 GT squared. There's one here that I never shared with you. This is a very useful one. It takes about, I don't know, 6 or 7 steps to derive so that you can know exactly why it works. But I just went ahead and wrote that you should use this. This is one of the formulas when you have distance and you have velocity and you have gravity. So it's just very useful. It's got a square. You're going to have to take a square root at the end, but it's not hard to use in this example. So let's look at this one. Billy, a mountain goat, is rock climbing on his favorite slope one sunny spring morning when a rock comes hurtling towards him from a ledge 40 meters above. Billy ducks and avoids injury. How fast is the rock traveling when it passes Billy? Okay, so really we want to know what is the final speed of a rock that starts at 0 and is propelled only by gravity. Okay, so if you know the distance and you know the initial speed, you can find this. Now there's other ways you could actually plug this in. The distance formula that you know before, the D equals VOT plus 1/2 GT squared, that would work too. This I just wanted to show you because there are a few of these. Now if you were doing lots and lots of physics problems, say for a test, aren't you glad you're not? There would be some that you would want to memorize some of these. I just want you to at least see it and do one together. All right, so let's see what we're given. We know that the rock came from 40 meters above, so we are just assuming that it started and it broke off of the mountain somehow, so this is going to be 0. So that means V sub O squared is also 0. We know gravity is 10, so this is 2 times 10 meters per second squared, and we know the distance that it fell is 40. Okay, so this is 40 meters. Okay, so now know that we're looking at V, the final velocity squared, so we're going to end up having to take the square root at the end. So we've got, when you take 2 times 10, it's 20 times 40. Okay, so this is going to be, so far, V squared, or V sub F squared, or final velocity equals 800 meters squared seconds squared, because it is also squared. All right, so meters squared over seconds squared. This is meters times meters, so it's going to be meters squared over seconds squared. So when we take the square root of this, then the meter squared will go back to meters, and the second squared will go to seconds, and your velocity will be in meters per second. So the square root, or V sub F, is going to be equal to the positive square root of 800 m2 s2, which is going to be equal to 28.3 meters per second. Right. It asks you a really neat question. How does this speed compare to that of a car traveling down the highway at 25 meters per second, which is equivalent to 55 miles an hour? So this is 28 meters per second, which is higher than 25. Okay, so it's going to be a bit faster. So you can say a little faster than 55 miles an hour. So you don't want to get hit with a boulder that's fallen 40 meters. It's a bad idea. It would ruin your day. Let's look at the next one. Reverend Northwick climbs to the church belfry one morning to determine the height of the church. From the outside balcony, he drops a book and observes that it takes 2 seconds to strike the ground below. How high is the balcony of the church belfry? Okay, so I guess you don't know how the belfry is, but at least he can climb to the belfry. So we know that it's 2 seconds. So here's the one that we've talked about several times. VOT equals 1/2 gt squared. So this is going to be initial velocity as he simply drops the book. So we don't have an initial velocity, so this goes to 0. And then we have 1/2. Okay, so I'm just going to say this is plus, and I'll multiply it. So it's 0.5 times 10. Okay, so 10 meters per second squared times 2 seconds. All right, seconds is going to cancel with one of the seconds, leaving you a velocity, leaving you meters per second. Okay, and this is squared, isn't it? Because it's times squared, so it's going to cancel it twice, leaving just meters. That's distance. That's good. That's what you want as distance. Okay, so half of 10 is 5. 2 times 5 is 10, and then 2 times 10 is 20, because you have to do it twice. So this is going to be equal to 20 meters. Okay. The second question said, why would it be difficult to determine the height of the belfry if the Reverend dropped only one page of the book? Well, if you've ever dropped a page, you end up that the air is actually floating it just like a feather. So there's a lot of air resistance. So a book doesn't have as much air resistance. It doesn't catch the air the same as a sheet of paper was, or a sheet or something like that that would be really easy to catch the wind. That's why you don't have your parachutes made out of books. All right, so my guess would be air resistance. Okay, and then the last one here. This is what we're talking about in the conceptual stuff today, hang time. Okay, so this is how long are you in the air when you jump straight up? So how long is Tina, a ballerina, in the air when she leaps straight up with a speed of 1.8 meters per second? Okay, so this is the simple one that we learned the other day. This is V equals AT. Remember VAT, V equals AT. And when we're talking about gravity, that's a special case of A. A is acceleration, gravity is a special case of acceleration. So this is just V equals GT. So if I know the acceleration, which is 10, all I need to know is how many seconds that she was in the air. But see, I don't have that. I know the velocity, and I'm trying to find seconds. So I need to solve for T. So let's get T by itself. G's in the way, so G is going to be divided into P, or into V. So I've got change of T equals change of V divided by G. Okay, so I've got, what is this? I've got an initial velocity and a final velocity built into this, right? You know, this is a change in velocity. So I'm going from 1.8 meters per second up to 0, because when she reaches the top of her the arc of her jump, she slows down to a stop. So that's why it's actually a change in velocity. Okay, so it's going to be let's just do that as a change velocity. She's going to start at V sub L. T is this over G. So this is going to be V sub F minus V sub I, or V sub O initial, over gravity. Okay. All right, so she's going to, her final is 0. Okay, that's why it's going to be negative. She's going up, she's going away from gravity, so she's going to have a negative number. So she starts at 1.8, but that's not her final, that's her initial. So this is going to be initial is 0. I'm sorry, her final. She jumps up and stops in the middle of the air and then comes back down. So that's final. Initial is going to be minus, then 1.8 meters per second. Okay, that's how she started. And then you're going to divide that. So that's negative 1.8. You're going to divide that by 10. Okay, which gives you an upward 0.18 seconds. Now here's where this gets a little bit weird. This negative meters per second, how do you go in negative velocity? You can't. You can't go slower than 0. So it's not like she's going so slow it's backwards. She's going up. So we call velocity positive when it's heading with gravity, and it's negative when it's heading away. But when I this is 10 meters per second squared. The meters are going to cancel. One of the seconds are going to cancel. You're going to end up with 0.18 seconds, but I'm going to ignore this negative because time is never negative. You can't have a negative 0.18 seconds. So this is just going to be it takes her 0.18 seconds to go up and stop. Now, what is her hang time? Her hang time is how long she's in the air. So you're going to have to double this. This is the time it takes to go to the top of the arc, and you're going to have the same amount of time to the bottom of the arc. So you're going to have to do 0.18 times 2, which is 0.36 seconds. Okay, you do not stay in the air very long. Even if you're an amazing athlete, you do not stay for more than about a second. You just don't, even if you're really, really good. Okay, I hope that helps.